All right, let's get started. So this mini course is called Data Science in R, and I'm your instructor. My name is Samuel Watson. You can call me Sam. This will be the first of 10 classes scheduled for the winter break. So we'll be learning programming, data manipulation, and data visualization. And the programming environment we'll be using for this is a popular statistical language called R. And we'll be starting from scratch here, and everyone is welcome to participate. We'll also record the sessions, and we're going to post them publicly on YouTube so that anyone who would like to watch the videos and work through the lessons asynchronously will be able to do that. So if you haven't seen Prismia before, I hope that you find it to be more dynamic and engaging than traditional slides or blog posts. So we're going to go for dynamism here in the form of engaging with the content rather than having a lot of interaction over Zoom. So one of the features that is going to be especially helpful for us is the built-in code cell. So what you can do is click on this R logo here, and you can type code in. So for example, 1 + 1, that's a thing R can do. And you click run. So the first time you click it, it will spin up a server to provide you with a computational environment, and it takes a little time. However, it will be snappy after that first one. So if for some reason you don't have a language there, or you have a different one, you can switch that by going up to the menu here, pulling your courses tab down, and then select this option to show R. We can also put code cells directly into the message thread like this. So this is an executable code cell embedded in a message. And you can click run here. Let me see if I've got my, still launching my Docker container. So I'm going to wait on that. But we can run this code cell, and we'll be installing the DS Labs package, which is a package that was made especially for the book that we're using. More on that in a moment. So one important note, if you're not used to this framework, is that the code cells are ephemeral. So if you refresh the page, or if a message goes off the screen to the top, then the things that you put in that code cell can disappear. If you want to commit something to your chat history so that you can go back and see it later, then what you need to do is put a note character at the beginning of your message. So you can type \note and hit the tab key, and that will create, when you send that message, it will add it to your chat history, and it will not send it into the central classroom. So you should see this actual note emoji if that worked correctly. Some more administrative stuff. This Prismia class has a message board associated with it. You might have gotten an email this morning with a link to the message board, and that is a new feature. So please bear in mind, there are going to be a couple of new features here that might be a little rough around the edges. Just let me know if something's wrong. But this does support anonymous posting. So, and it has more integrated code environment, stuff like that, than a standard message board system. So hopefully you like it. If not, let me know. So I want to demonstrate how multiple choice questions work, and also get a sense of the previous experience that folks might have with R. So I'll send you a multiple choice question. And what you want to do is just tap or click on your selected response here. All right, so I'll click over here to demonstrate the feature on the video. So you select multiple choice answer, and it's important that you click on one instead of typing something out, because you will get a response that's tailored to that particular reply that you made. So another thing that I can do to make the class more interactive is I can send a class response summary, so that you can see that 26 people said, I'm just getting started with R, and 11 people say I have some experience with R. Only one extensive experience, and it's been a while, however. We also have a brand new feature to try out. So again, bear with me if something goes sideways here. But this is a peer response question. If you see this busts and silhouette emoji, then what that means is that everyone is invited to answer. And after you answer, you will receive an answer from another student in the class. And then similarly, your answer will go out anonymously to another student in the class. And then you can respond to that student by just sending an ordinary message. So the very next message after the peer response that you get will go back to that individual. So, here's an example question, an open response question to get us started. So what are you looking forward to most about this class? That demonstrates the feature. You see this sort of peer symbol. So that's an anonymous peer. It's telling you this is their answer to the question. And then when I sent this response, then this person who sent this message received it as a private reply. Right, so thank you. So Brett was the person who received mine. And so if I hover over his icon here, it says his name and also that the message was sent privately to me, so that it's clear how that's working. So lots of great answers here. I'm going to share this part with the class as well, so that you can see what everyone is thinking about going into this class. Please note as well that you might not receive an answer every time. Okay, this is because answers are sent out in real time as they arrive. That way you get one typically very quickly after you send your message, and you have maximum time to reflect on what the other student said and respond to it. But the flip side of that is because it's in real time and it doesn't know how many additional messages might be coming in that it needs to match. You need at least 3 messages to be able to match and preserve anonymity. Because if you match a pair, then when that person responds to you, you know who messaged you. So it works in triplets, and so that means 1 or 2 people per question might not get an answer to look at. One more note. So in addition to answering multiple choice questions and open response questions that I'll ask to you, you can also ask me questions through Prismio or ask for me to clarify something. So I might respond to those questions. I might respond to you privately by text if I have an opportunity to catch a break while other people are formulating their response to a question. I can open up a private chat with you. I might also skip over your question depending on if I feel it's a good use of time for the rest of the class, but I can also go back and recover that question and respond to it after class and trigger an email notification to you. So do feel free to ask questions as we go. So one final administrative point about Prismia. So this platform is not at all specific to this course. You can use this platform right now to build your own content, either for an actual course you may be teaching or just to create content for other people to engage with online. You'll see that demonstrated after class today. I'll post this lecture video alongside the class script that we're using here so that you can work through this lesson asynchronously as well if you want to. And also the lesson that I'm going to share is something that you can copy, import into your own course, and then use to teach to someone else. So the idea is for this is to be very transferable and reusable without sort of instructors having to reassemble content from scratch. Speaking of which, the book that we're going to use for this course is called Introduction to Data Science by Rafael Irizarry at Harvard. And I'm very grateful that he licensed that work as Creative Commons, because that allows us to build on and remix that content here. So that's what you're going to see. It's going to be very heavily driven by the content of that book, but there are going to be lots of adaptations that I include for the particular context. So here's my statement to be in the clear legally with the license. The creative credit for the content goes to Professor Irizarry. Also, I'm modifying the content, so I have to say that to make sure that it's clear and no endorsement is implied. So if there are mistakes, please attribute those to me. They're very likely introduced by my transferring the content into this context. But some of the things that you will see will be original, including the way that I ask questions as we go. I didn't want to use the questions from that book and then provide answers to them, because that would undermine the value of the book to some extent if there's a sort of set place to go look and see solutions. So some of that content will be more original. All right, so the first section is going to be R basics, and we'll kind of start from the beginning here. So we'll be using a software environment called R. R is free. And in fact, you won't even have to download it to participate in this course, because we'll use the code cells built into R that we've already mentioned. However, you don't want to use R in Prismia as your dominant use case. This is really to reduce friction going back and forth between the Prismia chat window and your development environment, which I highly recommend RStudio for. So you can, if you're used to Jupyter notebooks, you can use R in Jupyter, but RStudio is really the gold standard here for the features that it has and how well adapted it is to R. So let's go ahead and get started. We'll start with some motivation. And by the way, this is the R basics section in the book. So here's our motivating example. So imagine that you live in Europe and you're offered a job in the US with a company that has locations in many states. And it's a job offer you'd like to take, but you've heard a lot about gun homicides in the United States and you're worried. So you see charts like this one, which compares the United States to various other countries, which have much lower gun-related homicides. Here's one from everytown.org, which shows gun homicides per 100,000 residents with the United States and various other countries. And the United States is several times higher than the second highest one on this list, which is Canada. But okay, you shouldn't look at a figure and trust your gut instincts about what it means. It's important to dive deeper. And one important consideration here is that the United States is a very large country by European standards. There are 50 different states, and there's a lot of variation from state to state with respect to things like gun homicides. And many of the states are very large. For example, California has a larger population than Canada, and Norway is smaller than 20 of the US states. Also, there are other concerns one might raise about the visualizations that we saw above. For example, not included in those charts are the murder rates in Lithuania, Ukraine, and Russia, which are higher than 4, which was higher than the US's 3.61. So it's possible here that the news reports are too superficial and you have more control over the situation than to just trust that gun safety is a big concern for someone considering moving to the United States for a job. So what we're going to work towards here is doing some analysis of this question, diving a little deeper, using R, using a data set on gun homicides in the United States, which is built into the DS Labs package that we're installing. However, before we do that, we need to take a big step back and learn some very basic R programming. So this is going to take some time. This is going to be the rest of today and also Wednesday's session, but it's going to be worthwhile. Okay, I want to take a question before moving to the next section. So from Michelle, can we download R on our personal computers? And the answer there is yes, I highly recommend downloading the latest version of R from the R website, and also downloading RStudio from the RStudio website. Okay, I don't recommend doing that now because it will be distracting and it's not going to help you at all because we're going to be evaluating the code cells here in line and you don't want to have to switch back and forth during class. But after class, that would be a great thing to do. What's the difference between R and RStudio? So R is the actual language which executes the commands that you give it, while RStudio is what's called an integrated development environment. So this is the context that you use to type your code, save files, access commands easily, look at arrays, sort of everything other than the actual execution of the code is going to be handled by whatever environment you're using to produce the code and inspect it and so on. So RStudio does that. It provides a lot of really great stuff. Both of these things are free. Okay, so let's jump into it. We're, as I said, going to go back to the very basics and we're going to build up from scratch. And we're going to start with the notion of objects. So suppose a high school student asks us for help solving quadratic equations. They're going to have a lot of them and they're going to take the form ax squared plus bx plus c equals 0. So this is the general form of a quadratic equation. If you're not familiar with that, don't worry about it too much. We'll quickly get into the programming side of this. But the quadratic formula, if you recall from middle school, is a piece of mathematics which gives you the solution to this equation. So instead of having to do some special work for every equation of this form, we can just plug the A, B, and C values for a particular equation into these formulas and get the two solutions to the equation. And programming languages allow us to do exactly that same sort of thing, assign a numeric value to a variable and then perform computations with that variable. So we'll write out the code like this. So we'll say, suppose that our equation is x squared plus x minus 1 equals 0. So that means A is 1, B is 1, and C is -1. So we want to make these assignments. So we'll run this code cell. And notice that it says loading or nothing returned. So this is actually a nothing returned case, because when you make an assignment in R, it doesn't return anything. So if we had made a mistake, we would have gotten an error message instead. So a quick note for people coming from other languages: to assign values to a variable, in most other languages, you use an equal sign, a single equal sign, instead of this arrow, this sort of less than hyphen ASCII arrow. And while the equal sign is more common here and is also acceptable in R, we do recommend using the arrow for consistency with how other people use it. Okay, so once we store a value in a variable, we can inspect the value of that variable by just running a code cell that just has that variable name in it. And R will tell us that the value that it has associated with that variable is 1. We can ask R more explicitly to print out the value of a variable using the function print. And this can be useful in some instances, when we'll see later, when just putting the variable doesn't actually produce anything. This kind of forces R to tell you what the value of the variable is. So as I'm going to take a question here from a moment ago and then continue on. So will we be using real life case studies as a part of the course? So yes, this is one of the great things about the book that we're using. And so because it's in the book, it will also be here. So yes, we'll go back to this murders example, and then there'll be examples throughout showing how there's interplay between the programming and analysis skills and the real life data problem solving tasks that you encounter. I think that's a really important dynamic, and that's something that I'm going to emphasize, although, you know, it's emphasized in the book, so I don't have to do too much work to accomplish that. Okay, so back to the lesson. So the word object refers to any entity within the programming environment that we create or manipulate. So for example, variables like A, we just defined to be 1 above, that's an example of an object. There are lots of other kinds of objects that we're going to see. If you don't know these terms, that's fine. But if you do, arrays, strings, functions, there are various more complex structures that will be introduced later. These are all examples of objects. So object is kind of an all-encompassing term for things that you manipulate in the programming language. So as we define objects in the console, we're actually changing the something called the workspace. So we can see all the variables that we've defined by typing ls and then open parenthesis, close parenthesis. And if we try to recover the value of a variable that's not in the workspace, we'll get an error. So for example, if I pop open my code cell here and I type something like X, which is not in the workspace, it'll say error, object X not found. All right, so we've got these values stored as A, B, and C. And what we can do is just type out this arithmetic expression. So the formula, the quadratic formula, this is the quadratic formula translated into code. So we just basically type out exactly what we see in the math syntax, except that we can't do, you know, things like big horizontal fraction bars. We have to do a slash, and that means we have to use parentheses to group the numerator as well as the denominator. And we have to put the asterisks in explicitly here. But essentially, this is just a transcription of what came before. I guess the other point is that square root is SQRT. It's a very common convention in programming languages. And we get our two solutions. In R, perhaps the second most important concept beyond variables is that of a function. So data analysis can typically be framed as applying a sequence of functions to the data. So you start with some raw data and then you transform it or perform some analysis on it. This can typically be framed as applying one function after another. And R has quite a few predefined functions that we can use to do statistical analysis. So this is an advantage of using a language like R, which is designed for statistics, as opposed to other languages which have statistics sort of bolted on. There's not as much sort of question about what package to use. You can use what's built into R. There's been quite a long time since the last question. The first couple of days are going to be more like that for this content. As we move forward, there will be a better balance of introducing new ideas and then having you do work on them. Here, though, I think it would slow us down too much because there is quite a bit of ground to cover in terms of basic pieces, and it's not a slog. So there's not as much of a reason to have a ton of questions embedded. But in any case, I do want to ask one question here, which is, what would you say is the essence of the word function? So what is the main idea invoked in your mind as a gut reaction when you hear someone say the word function? I'm going to share a few answers here. So the main idea is the association of an input and an output. So you supply some input to a function, that function performs some calculation involving that input and then provides an output. So that's the key idea. I will summarize this block for you so that if you want to go back later and see that, so people said a lot of things, but if you want to go back later and kind of see the spectrum of what folks think of when they hear the word function, here you go. There is a discrepancy between some programming oriented answers and some answers which try to be a little more general, encompass the math definition as well. And that's completely reasonable. You can think of functions purely in the programming sense or purely in the math sense, or in some way that tries to encompass both. By the way, another administrative point about Prismia, the circled R icon that you will sometimes see at the beginning of a message indicates that this is an open response question that's being registered, meaning that it will show up in the class statistics as a question which everyone was asked to answer. So if you would just answer those no matter what, even if you are just going to shrug, so you can do / shrug tab and get the little shrug emoji, that's helpful feedback for me so that I can see this is something that you don't feel comfortable formulating a response for whatever reason. All right, so we've seen one function already, which is the ls function. And what we saw when we did that, or when we used that function, is that we used parentheses immediately after the function name. So we did ls open parenthesis, close parenthesis. So that caused the function to perform its task, which is to identify the items that we've defined in our workspace. But the reason that function could have just open parenthesis, close parenthesis with nothing in between is that we don't need to supply any data to that function for it to perform its task. It's able to consult the programming environment that it's operating in to answer that question. In fact, it has to, because that's where the information is stored. But in most cases, you will need to supply some information to the function for it to perform its task correctly. For example, the logarithm function, which tells you what power you need to raise e to get that whatever particular number is supplied. You need to say what number you're taking the log of. So log of 8, for example, or log of a, we'll get the values of these two numbers. So remember, we defined a to be 1 earlier, so that's in our workspace, so the programming environment remembers that. And log of 1 is 0, so that's why 0 is printed here. Log of 8 happens to be 2.078, 2.079, whatever. So you can see how this works. I'll share this comment quickly. Is there a difference between R and Julia? And I would say Julia / Python / most other languages in the way that the things are printed. Yes, that's true. So every line, if it returns a value, that value will be printed out so that you can see it. And in many cases, it's only the last line that gets printed. So yeah, that is a difference. You're not born with knowledge of how all of the R functions work. You need good ways to get access to that information. And you can look it up online, of course, but you can also just call the help function with the name of the function enclosed in quotation marks. So that will allow you to read whatever information is prepared. Although this is a bit surprising. Doesn't seem like that help information is actually any good. So, well, here's another thing you can do. Yeah, that just gives the same information. So actually, I'm not sure what's happening here. It looks like it's giving the information about a different log function, a function that would log some information to, I don't know, some kind of file that you're using to store information. Anyway, let's do square root instead. I bet that one's better. There we go. Yes. So square root of x computes the principal square root of x. So this is how you want to inspect functions and see how they're intended to be used, what kind of output they give. So one of the things, the helpful things that's provided by the help page is information about what arguments the function expects. So for example, the log function needs an argument called x, which is a value you're taking the log of, as well as the base in order to run. But it's often the case that some of the required arguments have some natural choice that you can sort of build into the function. That way the user doesn't have to supply them. And the base is such an argument. So the base is e by default, which makes the log function here the natural log, because that's usually the one that you want in most applied math contexts. The base e logarithm is the one you want to use. So, but you can certainly change that. And the way that you want to change that is assign another object, just like this. So base equals 2. So that's going to assign the value 2 to the name base for purposes of evaluating this function. And since the exponent that we need to raise 2 to get 8 is 3, when we run this code cell, it will return the value 3. All right, I'm going to come at you with another question, keep you on your toes. Did this operation that we just performed involving this base equals 2 thing here, did it add a variable called base to the workspace? So nice job. The answer here is no. And we could inspect that by just checking the workspace. So we can do ls here. And we see that it hasn't been added. So the point is that assignments that happen inside the parentheses of a function call are just a way of clarifying the roles of the objects that we're supplying to the function. So they're not the same as ordinary assignments, which appear on their own line. Another difference between this kind of assignment that happens inside a function call is that you must use the equal sign. Don't use the arrow here. It will actually work to use the arrow, but it means something different in a way that can easily cause silent bugs. So this is a big no-no. This is a great question. If we have a variable called base in the workspace, would it affect the way the function works? And the answer is no, because scopes are handled in a reasonable way is the short way to say it. So the language knows that it should use the locally defined value and not interfere with any variables either way, either reading them or assigning to them. So these are called scoping rules that help the language determine in which situations to use which lookup tables. And sorry, I accidentally supplied a code cell with that one. Okay, so we have not been telling the log function what the x value is explicitly. So we can do this. We can say log of x equals 8 comma base equals 2. And if we do that, it's a little more explicit. We're not relying on knowledge of the order in which the arguments appear. But typically, you want to adopt a convention of using unnamed arguments when it's quite clear what's going on, and naming them only to add clarity. So log of 8 comma 2 could conceivably be confusing to someone because they might not know which comes first, either the base or the value you're taking the log of. And so if you supply the argument this way, it means the same thing, but now it's clear to someone else who comes along and reads it exactly which one of these two is the base. So supplying this additional named argument doesn't really help add much more clarity beyond that, but it's a judgment call. Also, if you don't want to remember the order, you can just supply the arguments names to every argument, and then it doesn't matter. So it knows which is the base and which is the value you're taking the log of, because you told it explicitly, and so it doesn't care that it's in the wrong order. There are some exceptions to the rule that functions require the parentheses to be evaluated. So these are typically things that are built in and very common operations that would be fairly burdensome to handle with parentheses. So for example, if you want to raise 2 to the third power, 2 times 2 times 2, that is something you want to be able to do with as few keystrokes as possible, because it's a very common operation. And you do it in R with 2 caret 3 like this. All right, so this is telling you 2 times 2 times 2 is 8, no problem. That's a function call to the exponentiation function, but there are no parentheses there. All right, quick question again. So which of the following work as intended? So if I do round of 3.141, supposed to be 59, comma 2, or if I call the second argument digits, or if I put them in this order, or if I name both arguments, which of these are fine and which are no good? So if we run this cell here, we see that the first 2 and the fourth give expected results, and the third one does something weird. So it's interpreting this value, which is an approximation of pi. It's thinking that's the number of digits, and it's thinking that this is the number we're trying to round. Okay, so this is the correct answer. Oh, this is interesting. Thank you for sharing that, Ethan. So let's try this out. So Ethan claims that we can actually supply digits equals 2 first. And yep, that works. So apparently what it's doing is it's pulling out all of the named arguments and assigning those properly. And then it's assigning the unnamed arguments in the specified order. So it's trying to be as flexible as possible with you. That's a great, that's an interesting little observation for us to include here. All right, there are other pre-built objects built into R, including many data sets. So this is a kind of, it's a nice thing about R that if you want to do something quick, just check something out, you don't have to find some data to pull in to get started. It's got it built in right there. So you can call the data function with no arguments, and it will tell you all the data sets that you've got here. So there are a lot of them. You can scroll down and check them out. It tells you the name as well as some kind of brief description here. We can pick one of these out and do something with it by just using the name. So these are also exposed at the top level for immediate use, all of these names here. So we can type CO2, for example, and we get this nice table showing us a time series. It's got columns correspond to months and rows correspond to years. And it's telling us something about CO2 levels. It goes up through 1997, apparently. Yeah, thanks, Brett, for clarifying the units on that. I did not know. And okay, so it's at some specific location. All right. There are some other built-in quantities like pi and infinity. So infinity is capitalized, pi is not. So we've used in our examples here for our own variables, we've used the letters A, B, and C, but there's no reason it has to be length 1. It can be basically anything. So it has to start with a letter. It can't contain spaces, and you shouldn't use variables that are named in R, not because you can't, but because then you might try to use those functions later and you've written over them. So you want to leave the values that R uses alone. So you wouldn't want to assign the value 2 to the install.packages variable, because then you wouldn't be able to install packages. I want to make an extra aside here, because I found it to be a very confusing thing that it turns out has a really simple explanation when I was first learning R, which is that the dot in R is essentially just treated like any other character in the context of a name. So in other languages, it often means something very specific, and then you see it in R and you apply those concepts from the other language to try to figure out what's going on, and you get very confused. The answer here is that you can just use the dot like any other letter. Like, and this is a ridiculous example, and you shouldn't obviously do this, but just to illustrate how much the dot is really just like any other character, we can assign the value 3 to the dot, and we can assign the value 4 to something that includes dots at the beginning of the end and something else in between. And then we can add these two values, and it's going to tell us that the answer is 7. So R didn't blink about the fact that we had dots mixed up in with letters, or even dot completely by itself. Yeah, so this is kind of a funny point. Also, I committed a transgression here. You might have noticed I used the wrong assignment operator. So this was my bad. You can tell this was something I added, because there's a, well, it's not exactly a mistake because it runs, but I don't advise doing what I did here with the equal sign. How do you unassign a value to an object? For example, you assign the value 3 to CO2 out of curiosity. Yeah, CO2 is gone. You have to restart your kernel at this point. You can't get the old value back. So a piece of programming wisdom is to use meaningful words instead of just plain letters. So in the quadratic formula, it's really fine to use A, B, and C, because that's how we know those values. We typically call them A, B, and C as names. So those actually are descriptive names, even though they're one letter. However, in most contexts, we don't have that kind of thoroughly consistent convention to rely on, and we need to spell out with more letters what's going on. So for example, you might call the first solution solution underscore 1, something like that. You could also you could also use dots instead of underscores here. That would be more consistent with how the base language is used, but the somewhat canonical Hadley-Wickham style guide recommends using underscores for this. Underscores are more consistent with how other languages work. Okay, so a few more notes about using R. So the values in your workspace are going to stay there until the end of your session, or you can erase them with the function rm. So this answers the one facet of the question from earlier: how do you unassign a variable? This will do it, but it won't recover the previous value. It will just remove it. But in any case, you can also save workspaces for later use. So this is not as common in other languages. In this is kind of special to R. So when you quit R, kind of famously, the program will ask you, do you want to save your workspace? So it sort of assumes by default that you want to be saving your workspaces. And then when you start it up again, it will restore that workspace. So this is not the recommended best practice for this. So what you want to do instead, if you do want to save a workspace, is assign it to a specific name instead of always stepping back into the same one. So our studio has some facilities for this. I'm not going to read this too carefully because you can look at it on your own, and it's not going to be essential for this course because we're doing everything in these ephemeral code cells that are appearing in the chat thread. Okay, so the next section here, we're going to look at the idea of a script. So suppose that we need to solve another equation. What we can do is just copy paste the code we had before, just change the variable assignments, and we'll get solutions to the new equation. So this all works as expected. However, that's going to get a bit tedious at some point if we're doing a lot of copy pasting. What we will often want to do as a way of separating concerns is once we solve a problem, we can put the code for that problem, for the solution to that problem, into just a plain text file on our computer using any editor that allows you to edit plain text files, including RStudio, which is the natural choice for doing this specifically for our programs. But in any case, we'll save a plain text file that includes this code somewhere on our computer. We can point the computer to that file, which is called a script, and it will run that code. So we typically save a script file with the extension .r as a way of reminding ourselves and also letting the operating system know that that file should be interpreted as R code. So if you have RStudio downloaded, for example, and you double click on a .r file, it will open in RStudio. Another point to make, which is actually a question asked earlier, is about commenting your code. So it's often recommended in various programming environments to add some English language in between the code to explain what's going on. That way, when you come back to it later, or if someone else has to read it, they won't have to infer all of the meaning from the code that you wrote. They'll be able to get extra nuance from the words that you use to describe the code. So for example, we're going to say here we're computing the solution, and up here we're describing the problem. And when we run this code cell, it doesn't run any of these lines that start with the asterisk. 2 asterisks are used here just for visual clarity. You can also just use 1. This makes the comment stand out a little bit more. All right, so the timing, I think today is working out quite nicely. We're coming into a couple of exercises I have at the conclusion of this section, and then we'll pick up in the book from there when we start next time. So here's my first exercise. So suppose we try to find the sum of the first 100 positive integers in the following way. We assign the value 100 to n, and then we use this formula, n times n plus 1 over 2, which tells us the sum of the first n integers. So that does not work. What went wrong, and how should we fix it? All right, so folks are all over this. We need to make the multiplication explicit with the times sign exactly. So when we put a variable name immediately followed by parentheses, that gets parsed as a function call. So if we do it without, it says, I'm looking for n as a function and I'm not finding it. That's because n is defined and it's a numeric value instead of a function. So if we just put the asterisk in explicitly, that solves the problem. Okay, so here's another little reminder question. So suppose you see a function called seq in someone's R script and you think, I wonder how that function works. What does it do? What kind of arguments does it take? What would be the quickest way to answer that question? Yes, so all of those work. you'll notice that there really is a lot of information here. Maybe take some time. I think it's helpful to look, well, certainly you can look at the arguments to get some important information. If you look down to the examples though, that can be a helpful way. All the way at the bottom, there's some examples. That can be a helpful way of kind of quickly getting a sense of what's going on without having to wade through some of the details. I mean, these are helpful in some situations to know really specific things about what's going on, but it says SEQ is a standard generic with a default method. What does that mean? So sometimes you might have to mine some information out of here, but in any case, that's the quickest way to see the documentation for a function. Okay, and that brings us to time. I'm going to halt the recording and stick around for a little while. If anyone wants to chat with me about how things went today, I'm very eager to get feedback. And that includes the participants in the program, but also those who are not in the DSI Master's program and might be coming to this with less experience. I'd like to get multiple perspectives on that.